So guys, this is still day one class. We are joining again after power cut. So thankfully I got the power immediately back. Otherwise, my UPS was not charged. So now point is, we were discussing in macroscopic approaches. So because we have less number of variables, because of that we have less number of equations. So I was talking because of this we have small syllabus if you compare MTech syllabus and because MS wise, syllabus wise you don't see, you see the depth, the research, R&D, all those things. So we have to do lot of things in MS, and of course your thesis and all will be like based on your professor or your guide or something. So main point is here, whatever properties we are going to discuss, this kind of thermodynamics we call as classical or engineering thermodynamics. For example, you may have heard about P.K. Nag book. If you see the book, what is written there on the book, it is written engineering thermodynamics. There are so many other books for engineering thermodynamics. If someone wants to learn things at molecular level, they should learn statistical thermodynamics. Okay, now let's go for another topic, what we say as a system and surrounding, environment and boundary. You may have heard what is called system, what is called surrounding, what is called environment and boundary. So actually based on everything I have given basic test series questions, even though concepts are very clear, but students are doing in those test series mistakes. They are doing mistakes in test series. So let's start with the basic idea of system. See guys, system means anything what is analyzed by student or scientist or professor or teacher for some specific purpose or practical in your college or in any company. That system where you are trying to judge property variation, system for which you are trying to judge temperature, pressure. I hope you're clear what is system. Okay, actually there is a political system in every country. We are not going to discuss. There is cricket system. You may have heard about ICI or something, some cricket system, cricket ICB something, Cricket Board of India. Those systems we are not talking. Our main thing is to talk about thermodynamic system. Okay, so any thermodynamic system is actually that quantity, or you can say it is a finite quantity of matter, matter, a finite quantity of matter we are considering for our thermodynamic study. Now here only another topic drops immediately, that is surrounding. Because for example, imagine this much zone I am covering, and this zone I am giving to student 1, and this zone I am giving to student 2, and I am saying to judge this much air available in this zone, and what is density, what is temperature, how the pressure is being changed on this wall and on this wall and on this wall. So all these works I am assigning to student 1. Similar work I am assigning to student 2. But this system name I am saying system B, and this system I am saying system A. Then how student 1 will decide that how much system he or she has to analyze. So that is actually divided or decided by using boundary. So immediately concept of boundary comes into picture. Okay, after system and before boundary we have one small topic that is called as surrounding. Surrounding is something which is not being affected whatever is happening inside the system. Whatever is happening inside the system, that is covered through a special type of boundaries. We have types of boundaries I will go through now. Other than system, anything else should not be affected because of system activities or any kind of experiment. For example, there are experiments going on International Space Station, right? On that station, whatever experiments are happening on the earth, we are not being affected because of the experiment. Not only that, on earth itself, still somewhere electricity is being produced because of nuclear reactions. Okay, so nuclear reactions are having its own hazardous effects, but we are sitting in our rooms and houses, we are not being affected. It means what? That system and we are surrounding. That place is system, we become surrounding. Technically, how will you say that? What is surrounding? Anything where intensive properties Intensive properties means which properties independent of mass or energy. They are intensive property. I will come to that point also. They are not being affected because of system work. Whatever we are doing into the system, our surrounding properties are not being changed. Especially what kind of properties you can judge easily. They are intensive properties, right? Now, what kind of surrounding we are talking in our thermodynamic study? We are not talking that kind of surrounding that experiment is happening in ISS and we are sitting on Earth. We are blasting something on Jupiter and we are trying to judge the effect on Earth. No. We are talking about immediate surrounding, or we call as local surrounding. It means what? Concept set of surrounding what we discuss in thermodynamics, that used to be our immediate or local surrounding. I hope it's clear. Good evening, Vedant. Let's go ahead. So actually after surrounding we have to discuss about boundaries. But before going to boundaries, let's discuss types of system. Actually we have three important types of system. But it's not like you will say, sir, open system, closed system, isolated. No. We have three types of system, thermodynamic system. When we say types, then all the types are based on few properties, right? So actually we have our first type of system, which is based on mass and energy transfer. So based on mass and energy transfer, we have first system we call as open system. Open system means like this: mass can enter into the system, and if mass can enter, then easily energy can also enter. Okay, energy can enter through the mass, or energy can enter in radiant way, or energy can enter using some work transfer, right? Anyway, there are ways to for the energy can enter. So main point is, if mass can enter, it is very easy that energy can also enter. Second one is closed system. Closed system means mass cannot enter, energy can enter in some other way. For example, there is a closed system, and here I have closed the system. There is no way to mass go in or go out. So I will put one shaft here, and I'll put one fan here, and suppose there is a water, and from the outside I will rotate the fan. Then work will go inside the fan, and after some times water will get heat up. Okay, temperature will increase. How temperature is increasing? Because whatever work we are supplying here, don't say work, whatever energy we are supplying here, that energy is going inside through the shaft, and then it is converting into rotational energy. That energy is striking with the particles, and particles are achieving their kinetic energy at molecular level, and because of that temperature is increasing, we can say, right? So that is open system, sorry, that is closed system. And then we go for third type of system, which is isolated system. Energy and mass both can't enter into the system. Not only enter, there is no interaction at all. You can't go in, you can't come out. U means mass and energy. I hope it's clear. Isolated system. Then we have second type of system, which is based on something else. We say spatial uniformity in composition. Means second one is spatial, not spatial, spatial. And uniformity, but in which? In composition. I hope you have guessed it. So based on this, we have two types of system. We have homogeneous system and we have heterogeneous system. It means homogeneous means whatever content you have taken, whatever matter you have taken, all the molecules are same everywhere. That is homogeneous. For example, a cup of tea we have. Okay, that cup of tea, if you taste for the first, yes, uniform, of course uniform. You take the first sip of the coffee or tea, you take the last sip of the tea or coffee, both will taste same. Amount of sugar, amount of thickness, amount of coffee, everything will be same. But other thing is heterogeneous. Okay, heterogeneous example, just an example, you take the example of dal fry. Okay, dal fry. In dal fry, you can see you have a plate. In this plate you have dal fry. So here you may have tomato, piece of tomato. Here you may have onion pieces. Here you may have some dhania. Dhania means coriander, something, right? So everywhere your content is not same. So it is heterogeneous mixture. Okay, so I hope it's clear. So whatever we are going to discuss, homogeneous system and heterogeneous system, they are actually based on the phases also. means you have a system which contains homogeneous only homogeneous medium, and you can have system which contains heterogeneous medium. That's why we have two types of system. Means what? Even though your system is homogeneous, it can be open, close, or isolated. Even though your system is heterogeneous, it can be open, close, or isolated. Clear? Then we go for based on the third one. We go for based on mode of work and energy transfer. Mode of work and energy transfer. Now see here, don't be confused with the first open, close, or isolated system. Actually, based on work and energy transfer. You see, first type of system we call as simple compressible system. Very few people know about this name. Simple compressible system. Now second one you can say as non-simple compressible system. Okay. Now we have to discuss about these things. So we are not going to waste in our simple things. We are going to discuss our mainly these two things, because remaining things you understand well, so we can save our time. Actually, if you have any simple or simple compressible system, actually simple means what? Only one mode of work. Only one mode of work transfer is allowed. If that is simple system, means only one type of work we are allowing into the system or out of the system. But of course, heat transfer is separate. Heat transfer is also allowed. But there can be different modes of work transfer. How can you say different modes of work transfer? Let's understand. If I am saying only one type of work transfer, but at the same time I am saying more than one type of work transfer. What is the meaning? See on the next page. Suppose you have a system. In this system, I am giving you one shaft. With the shaft, I am giving you a fan. So if shaft will rotate, one type of work will go in. Imagine I have this piston cylinder arrangement. So if I push the piston at the same time, then other type of work input is there. So this is different type of work, this is different type of work. Means what? If you have got more than one type of work transfer, then this became non-simple. I hope totally clear. Actually, main point is, especially this particular system, what we call as simple compressible system, this system is actually studied only for quasi equilibrium processes. So now after this, if we discuss, that used to be more core of thermodynamics. So immediately we are switching the topic. Now we are jumping to our boundaries. New topic is types of boundaries. So actually guys, we have several types of boundaries, especially again boundaries are also divided. So your boundary, if you see first type of classification, it can be real boundary or it can be imaginary boundary. If boundary is if boundary is real, then we show the boundary with a straight line. If it is imaginary, then we use dotted line. I will give the example. Another classification of boundary is, you can have, I hope you understand what is the meaning of real boundary and imaginary boundary. In example, you will understand in detail. Another type of boundary classification is, your boundary can move or your boundary can be fixed. Now let's understand then in detail. Suppose you have a balloon like this. Now you are filling air inside. Okay. And any student wants to judge what happens only in this much zone when air is coming inside, or some other student is interested what is happening only in this much zone. So when air will go inside, then slowly this zone will change its shape. So just imagine, after some time, after filling some air, this became the zone shape. Okay, suppose this became the balloon shape. It means what? If you can see here, you have real balloon skin present, but this much is not real, because a student is set to discuss only this much zone. It means only this much zone. So in reality, here you don't have any boundary. There. But a student cannot study after that, because after that some other student will study. I hope it's clear. It means what? Here I will put dotted line and I will say this is imaginary boundary. Okay, now point is, what is real boundary? So the real balloon skin, that became your real boundary. Other example to understand this real and imaginary. See here, real and imaginary. Suppose you have a cycle pump. In this cycle pump, this is any pipe, something like this, and we are going to fill a tube. Okay, so you have any piston cylinder arrangement here. You press this, then what will happen? The air will get compressed and air will go here. But imagine if I am saying you that one student will study only this much as system middle, or you can say system pipe, or one student will study system tube, and one student will study system cylinder. So in case of system cylinder, student has to design boundary, correct? So student will design boundary like this, like this, like this, like this. So you can see this boundary, the top boundary, which is attached to the piston. That boundary is actually moving, because when piston will come down, boundary will also come down. So this type of boundary I can say movable boundary. But we have another type of boundary which is fixed boundary. Which one is that? You can see the bottom boundary, which is at the bottom of the this pump. Okay, this boundary is not going to shift anywhere. So this boundary is fixed boundary. And what about these boundaries? What about these boundaries? So actually the wall is fixed. The wall is fixed. So boundary attached to the wall we say fixed. And what is real, what is imaginary here? So in this diagram, all the four boundaries are real boundaries, because this is also attached with the piston wall, this is also attached with the cylinder wall, cylinder wall, cylinder wall. So here we have all the fixed boundaries. But if you see exactly here where we have connection of pipe and connection of cylinder, there you have hole. So where you have hole, there you have to put the dotted line. For example, suppose this is the cylinder part, this is the pipe part. So do you guess my point? Exactly here you have hole actually. Then only air can come from that to this. Okay, I'm zooming this. So air can pass here. So here we have to put a dotted line. So this dotted line will show you it is not real boundary, it is imaginary boundary. So first thing, it is imaginary boundary. Next thing, it is fixed or movable? It is fixed actually, because it is not moving. I hope everything is clear. Then other than system, surrounding and boundary, whatever is remaining, we call that as universe. Okay. Now I can ask one question. I am giving you a fan here. Okay. And here I have fan blades. And imagine you are opening a fan company, and for that fan you are simulating this in any software, and suppose using CFD you are trying to judge the flow behavior over the fan blades. So you may be knowing, if you have done some CFD course or any related software, that we used to put, there is something called boundary condition. I will teach you this this topic, boundary condition. So suppose I am giving boundary condition from here to here, and color change, temperature gradient, pressure, everything I am deciding in the software, and I am creating, using dotted line, I am creating this. So whatever is happening inside this, I am going to take record of everything. So my first point is, first question, this system whatever I am going to analyze, that is open system or closed system? All the students tick on the screen. All the students tick on the screen. Fast, everyone fast. Any new students, whoever is having problem, they are not able to tick on the screen. I will explain how to tick on the screen, how to use pen. Okay, let's go ahead. See guys, this is actually open system. Why open system? Because mass can enter into the system and mass can go out of the system. Okay, no doubt. Now my next question, this boundary is real or imaginary? Tick on the screen. Yes, you guys are correct. This is of course imaginary. Very good everyone, very good. All of you are correct. Now let's change the topic, and we are going to discuss our next where we are going to discuss thermodynamic properties. So thermodynamic properties. So I hope you guys have got that whatever topics we have covered, based on those topics you have to write test series, and topic is not tough, so you can directly go to the test series after class. Okay. And tomorrow we'll be discussing a test series. Anyway, I will update properly in the WhatsApp group what are the test series you have to take. Don't worry. Now you go to the next topic, thermodynamic properties. Guys, see, in thermodynamics, whatever properties we have, if you remember in our physics class in ninth grade, we classified our properties as scalar and vector. But when we came to engineering, then we defined our properties based on some energy transfer, and we call them as point function and path function, right? So whatever thermodynamic property we have, we are going to define as point function and path function. Idea is very simple. Mathematically we have to define the property. Okay, so for that I am giving you a question, and first you will take the question. After that you will understand the meaning of this lecture in detail. Suppose I have any property P, and I am saying that this property is defined by the equation x square plus y square bracket dx plus, again it is defined as xy dy, and our job is to discuss whatever property is this. I am not sure which property is this. Whatever property is this, this is point function or path function. Just by seeing the equation we have to judge this. Okay, it means what? Now we have to know the technicalities of path function and point function. Okay, anyway, if you see directly what is path function, so whatever properties you can't store, whatever properties you can sense only at the boundary of the system, those properties we call as path function. Best example of path function is heat transfer and path transfer. Very soon in the upcoming part of the lecture I will explain. There is one special work that is not the example of path function. I will explain in the upcoming lectures. Now see, in point function it is very clear. It does not depend on the path. It does not depend on yeah, correct, it does not depend. Yes, Vedant, what yeah, correct, you are correct. Don't text actually, now I am being distracted if until you have any doubt. Okay, next point. Actually path function and point function, whatever we have to understand based on a mathematical ground. Okay, I am going to give you one idea. How will you judge this property P? Very easy. Actually see, whatever point functions are there, those point functions are going to be exact differential. Now if you have done differential equation chapter in mathematics, anyway I am going to teach this in upcoming lectures, but if you have done in your college days, then you can easily judge how to solve this property. So if any property given is exact differential, then it is definitely going to be a point function. Point function is also known as state function. I am changing the page, I am going to explain further. See here, if any property P is defined as suppose m dx plus n dy, then your job is whatever m is there, that m is nothing but dou p by dou x for constant y, and whatever n is there, that is for dou p by dou y for constant x, and after that you have to use dou m by dou y for constant x is equal to dou n by dou x for constant y. If these two people are matching, then directly you can equate and you can say the given property is point function. But the problem is you should know what is your m, you should know what is your n. How will you know what is your m, what is your n? Coefficient of dx is your m, coefficient of dy is your n. So that m you differentiate for y by keeping x constant, and coefficient of dy is your n. So differentiate n with respect to dx by keeping your y constant, and see if they are equal, then definitely that property is point function. Point function is also known as state function. Okay, I hope you can do this easily, right? So equation is given here. In this equation, coefficient of dx is your m, this property is your m. If you differentiate the m with respect to y by keeping x constant, so you are going to get 2y. This 2y must be equal to that property which is coming after differentiation of n. This is your n, differentiate for x, so you are going to get y. So you can say this is 2y but this is y, so they are actually not equal. So this property is not a point function. Okay, now clear. So property is not a point function. The property what I have given in the question, that is not point function. Now I can change my property, right? Let's go ahead. What is exact differential here? So just now what you have done, like dou m by dou y for x constant, dou n by dou x for y constant. Whenever any property is following this pattern, you will say that property is exact differential, and in thermodynamics exact differential properties are known as point function or state function. I hope it's clear. And some more theoretical points are there about point function. Point function is anything which depends only on initial and final position. They does not depend on the path. Just an example. First, I am giving you one very popular example. Suppose there is a car and this car goes from point A to point B. Okay, and in the car, suppose any student A is sitting, and student A has taken 1000 rupees borrow money from friend student B. Now student A is using car and going to student B place, and student A will deliver 1000 rupees. Okay, and borrow is done. But problem is, when a student started, that time student B called, don't follow this path because of rain, road is not good, so you'll get stuck. Then student A is asking, okay, which path I should follow? Then student B said, okay, follow this path. Okay, suppose student A followed this path and reached to student B. So in this process, what are the properties are changed? So you can clearly see time taken on this path and on this path are different. Next, amount of petrol or diesel, you can say fuel, of course, in this path. So you can clearly see the properties, whatever is being affected because of path, they all are path function. Properties whatever are unaffected, for example 1000 rupees, whether the person comes through this path or this path or this path, he will return or she will return only 1000 rupees, correct? That amount will not change. So that depends on the initial and final condition. If you will meet, you will pay. If you will not meet, no problem, no pay. So 1000 is not being changed. That is point function. In thermodynamics, clearly understand. Suppose this is your pressure and volume diagram. Okay, so if you are reaching from this point to this point, you are using this path. So this path is actually a process. Actually, path, process, properties I will take in upcoming lectures. So if you are using this path, then area under this path gives you work. But imagine if you are following this path. So this is actually different type of process. You may have heard there is isochoric, isobaric, these different processes are there. So which process you are following? So according to that, you can say area under the curve is being changed now. So amount of work done is changed. So work done is actually depending on the path, right? But again, I am saying there is a special type of work. Okay, I am giving the name now, that is called flow work. Flow work is that work which is definitely a work, but it is not a path function. It is actually a point function. Very less people know about this, that there is a special type of work that is flow work, and it does not depend on the path function. It does not depend on the path. Direct formula of flow work is P2 V2 minus P1 V1. Okay, remaining formulas of work is not like this. Let's go ahead. If you change the path like this, then also this is your constant pressure process, isobaric process. This is your constant volume process. So through these processes, you are covering maximum amount of work. You can see here. Okay, let's go ahead. So I hope point function clear, path function clear. Point function depends only on initial and final conditions. Path function depends on the path covered. Okay. Now we go for best examples of path functions in thermodynamics, gas dynamics, aircraft propulsion. You will be seeing only two types of properties. You will be seeing heat transfer and work transfer. Only these two properties are path function. But of course, if you will consider friction also, then friction is also a path function. But friction and all we don't have to discuss like a mechanical engineers. That's why you can skip this point. Now you go for another topic, that is extensive and intensive quantities. Very easy to discuss. Extensive, you go through the word extensive and you go through the word intensive. Best part is intensive. In focus on the word independent. So trick is intensive, independent and intensive. Intensive, independent means independent of mass. Whatever properties they are independent of mass, they all are intensive properties. I hope you got the trick. Okay, IN for independent, IN for intensive. So intensive properties are independent of mass. If you increase the mass, if you decrease the mass, that property will not change. For example, temperature. Just an example, temperature. Imagine you have a cold drink. Okay, in this bottle you have cold drink, And this cold drink, suppose this is 2 kg. I'm not saying in liter, I'm saying in kg. I'm saying in kg because I want to focus on mass. So suppose you have 2 kg cold drink and you have small glasses, and right now suppose this temperature is 20 degrees Celsius. So you are pouring a small amount in this, small amount is in this, small amount in this to enjoy the cold drink. So this 20 degrees Celsius will reach to all the small glasses. So they all will be 20 degrees Celsius, 20 degrees. Now you can see here mass is 2 kg, but still temperature is 20 degrees Celsius. But here mass is less, but still temperature is 20. Temperature is not being changed. So independent property. Temperature is independent property. So there are so many names you can guess easily. Independent properties. Independent. Density is independent or dependent. Huge problem among student. My question is, density is independent property or dependent property? Think based on mass. Reply fast. All the students, tick on the screen. Tick on the screen. All the students, tick on the screen. There should be total 50 students I was expecting tonight to join the class. But only 16 students are joining the class. Actually, remaining students are enjoying the live, like full batch, regular batch recording. Okay, actually guys, see, density is independent property, but how can we be sure that density is independent properties? Just an example of gold. Okay, you purchase a ring, you purchase bracelet, you purchase chain, or you purchase anything. Same gold, same carat, suppose 24 carat gold you are purchasing. So same 24, so density is same, correct? You purchase a small weight or more weight, right? I hope it's very clear. Just another example. You go through 1 kg copper wire or you go for 100 kg copper wire. Density of copper will be same, right? Copper is copper. Molecular arrangement you can change. Copper is copper. So that's why we define independent properties. So density as independent properties. So there are so many properties, but I don't think that this much easy question they will ask in GATE Aerospace, that which of the following property is independent property. But actually thermodynamics is our very basic subject, so definitely they can ask also. Okay, so like volume, energy, heat transfer, work transfer, these properties, they are extensive properties. But if you go ahead, temperature, density, pressure, specific volume, not the volume, specific volume, they are independent properties. Now once specific and these kind of properties are done, then I can ask you some important, very important question. There definitely you are going to confuse. Okay, I am giving you a question. Which of the following properties are not extensive? Are not extensive. You take option 1, pressure, you take option 2, temperature, you take option 3. Now I am giving you energy, you take option 4, heat transfer. So pressure, temperature, energy, heat transfer. Now you tell me, you guys tick on my screen, which of the following properties are not extensive? More than one option can be correct. Do fast. So it's very well clear that not extensive means intensive property. I am looking for intensive property. So pressure and temperature, they are intensive property. Okay, energy and heat transfer, they are extensive properties. Okay, now we'll go for something called total and something called specific. After 5 minutes, after this topic, we'll stop the class and then we'll meet after dinner. So see here, total and specific properties. So in case of total properties, actually total property is defined for total quantity. Total quantity means whatever mass is present. Suppose if 5 kg mass is present, then for this 5 kg complete mass, what is your volume? For this 5 kg complete mass, what is your energy? For this 5 kg complete mass, what is your enthalpy? I hope it's clear. So these properties which is defined for the total 5 kg mass, They will be total volume, total energy, total enthalpy. But if the same property you divide by with given mass, like 5 kg is given, right? So you find out for 1 kg. So then 1 kg data will become your specific quantity. Don't be confused. I am not teaching total property. I am teaching total quantity and specific quantity. Okay. Total quantity is defined for total mass. Specific quantity is defined for 1 kg, or you can say per kg, or sometimes if you change the country, then unit will change. Then per unit mass. Okay. In SI system, we take 1 kg. I hope it's clear. For example, volume. So capital V if you are using for volume, then small v you will use for total volume divided by mass. So mostly specific quantities we divide total quantity by mass, only by mass, not with weight or something else, right? And specific quantity symbols we use small alphabets, total quantity symbols we use capital alphabets, right? Now let's meet after dinner at 9:30 and we'll complete further.